Let us see what are basic statistics. Before we get started with any of the machine learning algorithms, it's good to understand some of the bare minimal basic statistics. These fundamentals are important for us to understand the advanced machine learning algorithms. Basic statistics and data cleaning. These are the two fundamental concepts. Before jumping onto machine learning, we should have a good hold. Today, we will discuss basic statistics. In a different session, we'll be discussing data exploration, data validation, data cleaning. These are very important because any machine learning model is as good as the data. We need to have a good understanding of the data. First, let us understand basic statistics. These are known as basic descriptive statistics. Descriptive stands for describing the data. You know what these statistics do? They describe the data. For example, if I gave you 1,000 customers and their income, monthly income, customer 1, his income, customer 2, his income, customer 3, his income, customer 4, his income, like that, customer 1,000, his income. And I asked you to summarize this data for me. I asked you to describe this data for me. I don't want you to print this data and show me. I want you to describe or summarize this data, 1,000 records. What are the measures that you are going to give me? Tell me in the chat window. Tell me, what are you going to give me in the summary, or when you are describing, what measures you will give me? Tell me. You will give the count, total number of records. Perfect. Very good one. Sum. Perfect. Super. Mean. Super. Mean. Mean means average. Average income. Minimum income. Maximum income. These are the ones that you are going to give me, isn't it? These are descriptive statistics. These are descriptive statistics. What are descriptive statistics? Statistics or statistical measures that are used to describe the data. We already, all of us in the classroom, we already have used descriptive statistics in our experience. Only thing is, we don't know their technical names. Here are the names. There are measures of central tendencies. There are measures of dispersion. Let us see what are measures of central tendencies, what are measures of dispersion. Measures of central tendencies. Mean is a measure of central tendency. Mean, which is also known as average. This is one of the first descriptive statistic that we calculate, isn't it? Mean is the most widely used descriptive statistic. What is the formula for calculation of the mean? What is the formula for calculation of the mean? Tell me. It will be sum divided by count, isn't it? Yeah. So mean or the average equal to sum divided by count. That's how you calculate. Mean will tell us what is the average value or the center value. I think we don't need to really discuss in depth about mean. Already all of you, most of you have already used mean. Now in Python, if you want to calculate mean, you don't really need to calculate the sum, or you don't really need to calculate the count. What you can do is you can already use a ready-made function called mean function. Okay. So let us see how it is done. There is a data set called census income data. This is the 1990 USA census data. 1990 USA census data. It is available on their website. We can download it. In that data set, there is a column called capital gain. I want to find its mean. For that, what I should do is first import this data set. Import this data set. Let's say I have imported it to a Python pandas data frame called income. Income is my data frame name. After that, you write data frame name, column name, dot mean. Okay. So let us go to the code file. All of you, how do we access the code file? We go to Google Classroom. How do we go to Google Classroom? We type Google Google Classroom. That's it. Google Classroom. Classroom.google.com. All of you have already enrolled to that classroom, right? Batch 6.
Yes, sir.
Yeah. Batch 6. Click on batch 6. After that, at the top, you see 3 options. Stream, classwork, people. And which is the option that I should click here? I should always click on. We will be by default landing on stream. But for accessing the class files, you should always click on classwork. All of you acknowledge this point, make a note of it. You will be clicking on classwork. Okay. Once you have enrolled, you don't need the link anymore. What is the process? Go to Google, type Google Classroom. You don't need to re-enroll. Like once you have enrolled, for lifetime, you will be able to access. That means you're already part of that classroom. Your Google account is already attached to that. Directly, you can go to Google Classroom, click on classroom.google.com. You will be able to see this classroom. Try that, everyone. First, let us try that. First, confirm this to me. All of you go to Google Classroom. Type this. As I'm speaking, you can type this. After that, click on classroom.google.com. Can you find this link?
Yes, sir.
Yeah.
Yes.
Click on that link. Chandra Prakash, you with me?
But I don't see the batch 6 one.
So for me, different batches, it will show Deloitte, Oracle, Optum, etc. For you, batch 6, this one will be shown. Hey, can you see that?
Yes, sir.
Chandra Prakash, you were able to see this? Batch 6?
No, I see one which is of uploaded on 2020 October. I see only that.
No, there is a folder of basic statistics.
Okay. Yeah. I'm able to see.
You
Sorry.
already inside this, is it? Chandra Prakash?
Yes.
Okay, you clicked on this. Okay, that is a classroom. So that's how you get into classroom. What I'm trying to say is you do not need the link every time you want to access the class file. Since you're already enrolled into the classroom, next time onwards, directly you can access it. Okay. Tomorrow or day after, even like this is lifetime access. Anytime at a later point of time, you want to access the class files, you have to go through this route. Now, this classroom is available to only those who have attended last couple of sessions. I think Bhuvnesh might have enrolled you to the classroom. Anybody missed the last 2 sessions, directly came to this session here, you do not have the classroom access by any chance? Anyone here like that? No, all of you are part of the classroom. Now, can you please confirm whether you can see this screen in front of you? Monica, you were not part of the last class, is it? Kondappa Naidu and Monica. You did not get a chance to go through the videos as well, is it? Maybe do one thing. I'll directly give you the link for the code. Somehow, just for this one session, you try to manage. Try to watch the videos from the previous session, somehow enroll into the classroom. Okay. And then try to fix the backlogs quickly. Okay. Will you be able to spend some time during this week? Yeah. On the last sessions, enrollment and all that. Is there any other person in the classroom who can help you? Monica and Kondappa, anybody can help these 2 people? Any of your friends who have attended last session, apart from just the classroom videos? If anyone else can help them, it will be great. Okay. Yeah. I think it is pretty straightforward, but now that like remaining 30 people are there, let's not, let's give respect to their time. So try to spend some time during this week, try to enroll to the classroom. Now, Once you are in here, all of you look at this. By default, Google Classroom will land you in stream. Okay. What you need to do is you have to click on classwork. Always click on classwork. Once again, by default, you will land on stream. Always click on classwork. Okay. Can you please confirm that to me? All of you are inside classwork.
Yes, sir.
Yes. Confirm that to me in the chat window. All of you, are you in the classwork? Mustafa is there already. Let's wait for others to confirm. Yes. Almost everyone is there. Vijay is also there. Perfect. You are inside classwork. Within classwork, basic descriptive statistics, Python programming basics, that is topic 1, basic descriptive statistics. Then other topics will be uploaded. What all topics will be uploaded? Python data manipulations will be uploaded, regression analysis, logistician, all the topics one by one, one by one, one by one. As and when we discuss the topics, their assignments, everything will be uploaded here. Some of you already started doing assignments. The first assignment, isn't it? And there were some
Yes, sir.
discussions going on and all that. Remember, this
Yes.
course is incomplete without assignments. If you do not do the assignment, just attend the course, then you will not going to take the maximum benefit out of this. Okay. Assignments are very critical, probably the heart of this course. Okay. Even if they are getting late, it's okay. You work on it at your own pace. Go to basic statistics class material. When you click on it, you will see data sets, code file, slides. The .pdf is nothing but the slides. Click on basic statistics code. IPYNB is the code file. Click on that code. It will open like this. Otherwise, I'm going to give you this link. People who did not join the classroom also, anybody will be able to open this link that I have shared in the chat window. The link that I have shared in the chat window, now everyone can click on that. Either you can access this code file using this method or directly go here. Once you are inside this, send me a confirmation message. Once you can see basic statistics code, either from here or by directly clicking on my link. All right, now let's get back to the business problem. The problem is, can you please paste the link again? Okay, here is the link. Here is the link. Vinod, can you access the link now? Yes, okay. Let's wait for others to also confirm. Anybody who's not able to view this code file, quickly let me know. If you're not able to view this file, please let me know. Since these are initial few sessions, it may take some time for us to get used to this. So we have to be patient. Okay. Some of you might be thinking, like, some of you might be doing this easily. Maybe you may have the previous experience. All right, now what I want you to do right now is I want you to import the data, census income data, import this data set. How do you import? How do you execute this? How do you execute here? Control enter or shift enter or simply this button. You can use run anyway. Look at this option, run anyway. Click on that. First cloud instance will be initiated, which means a Google Cloud RAM and space will be allocated for you. Then the command will be executed. This is the dataset name. pd.read_csv stands for pandas from pandas package. I want to use a function read_csv for reading this particular CSV file. A CSV file has been stored on GitHub. You can also follow the link, have a look at the CSV file. This is the CSV file. I want to import this CSV file, store it in income. What does income shape do? Any idea? Income short shape is giving me this output. Can you tell me what does this mean?
Columns and rows.
Hmm,
Number of columns and rows.
wrong.
Number of rows and number of columns.
वही तो option बचा है ना फिर. So it will give me number of rows. The second one is number of columns, right?
Yes, sir.
And then what does income.info do? Out of all these
Displays all
15
the
columns,
data types.
what are the string object type? What are the integer type of columns? What are the numerical, non-numerical? How many null values, non-null values, etc. Can you see the column capital gain here? What I want you to do is calculate the mean of capital gain and let me know. So tell me the mean of capital gain. What is the mean of capital gain? I want everyone to respond. 1077.64. Check that out. Is that correct? Let's wait for others to complete this. Amit, are you there? Not receiving messages. Chetan. Yeah, Santosh, go ahead. You have a question?
Yes, sir. One question: that dataset which you have uploaded from the GitHub, so it is already saved there. Like, if we're going for any organization, that dataset will be provided by us, or how it is like, what, where, like, how we'll import that?
Okay, so if the data set is locally stored, okay, we give the location of that local address. So here, this is the address for this one. Okay, if it is locally stored, we will give like C hash and local address. So all that you need to give is complete path along with the file name, along with the extension. Okay, right now this data set location is this one. We just need to give the data set location. That's it. So here my business requirement is, in this income data, there is a column called capital gain. I want you to find the mean of the capital gain. So for you to find this, I have to provide you this data. So imagine I have provided you this CSV file. In that there is a column called capital gain. I want to find the average value of the capital gain. Yeah.
Okay, sir. Got it.
Yeah. The question was, how did I go to that CSV file? If you hover your mouse here, Prabhakar, come here, try to hover your mouse here. Okay. You will get this control plus click, follow the link option, right? You can click on that. Then it will open this CSV file. Got it?
Sir, how to convert that data set into CSV file?
Converting into CSV file in the sense, this is already a CSV file. This data set is already a CSV file. That means from a database, when we are extracting, it has been exported as a CSV file only.
No, how to means it download, we can download that file.
Oh, you want to download it, is it? Into your local system, is it?
Yes, sir.
You can do Control S. Control S maar do. Yeah.
Thank you, sir.
Click here, Control S, CSV file. All right. Now, have a look at this. Mean value of capital gain is 1077. The average capital gain is 1077. Now try to answer this question. What is the average monthly income of a person in India? Do you have any idea? The average monthly income of a person in India. Can you make a guess? Try to make a guess what that could be. If I go to India, full India, east to west, north to south, village, towns, everywhere. What
Sir,
will be
5 to
the-
10,000. 5 to 10,000.
Some people are saying 5,000, some people are saying 10,000. Some
16,000.
messages 16,000, maybe correct, may not be correct. Some people are saying what 7,000. Some people are saying 24,000. Some people are saying 20,000. Some people are saying about 30,000, like that. What if I tell you the average monthly income of a person in India is 75,000 per month, including villages, including small towns, big towns, east, west, north, south. If you calculate the average value, you will get 75,000 per month. Will you believe in this? Does that seem
No.
correct?
No, sir.
It seems
No, sir.
extremely wrong. It's impossible to be that much, isn't it? Because we live in India, we know how the situation is. We may not know the right answer, but we know this is wrong answer, isn't it? That much confidence we can give, isn't it? Maybe I don't know what exactly is the right number, but 75,000 per month, everybody. Almost like how much? 9 lakhs per annum, everybody on an average. That is impossible. But you know what? When you calculate the average value, you will get this. How will you calculate the mean value? My income, your income, everyone else in the classroom income, etc., etc. Everybody's will be income will be in the numerator. Along with us, there will be a person called Ambani. His income will also be there. Plus and so on, everybody's income plus Adani. His income will also be there, plus and so on. What is Ambani's income, monthly income? Very simple, some 60,000 crore. What is Adani's income? Somewhere around 15,000 crore. In fact, during lockdown, their income even further increased. Reliance share got almost doubled. Now in the denominator, I'll be counted as 1, you will be counted as 1, everyone will be counted as 1, 1, 1. Ambani, will he be counted as 1 or he'll be counted as 1,000 because he is earning more while you are calculating mean?
1.
No matter how much he earns, he'll be counted as 1 only. Adani will be counted as 1 only. In the numerator, we are adding huge lump sum amount. In the denominator, we are simply not changing anything, 1 only counted. The data in real data sets, if you go to the real data sets, there will be always some points like this, which are very different from the rest of the points. In the real world data sets, there will be always some points that are very distinct from the rest of the points. You know what are they called?
Outliers.
Outliers. What are outliers? There are some points in the data that are very, very different from the rest of the values. The whole rest of the data, 95% of the data stays here. This data stays very far away from them. If there are outliers present in the data, mean is not the true center. Mean will be influenced by the outlier. Mean will be pulled by the outliers. Mean is going to give you wrong indication. It is not the true center anymore. Mean, the calculation of the mean is such that it has some caveats. Because until now in our life, if you want to find the average, we have only one measure. What is it? Sum divided by count. But there are some places where it utterly fails. We need to be careful. Especially in which case mean fails? Tell me. In which case, when there are outliers in the data, mean fails. There has to be a different value. There has to be a different measure. Look at this data. When I see this data, I think the mean value should be 1.5 or 1.4. But when I calculated the mean, I got 2.5 as the mean. Can you tell me why 2.5 is the mean here? What could be the
Because
reason?
of 9.
9 outlier.
Because there is one outlier here. Statement number 1. In this data, 90% of this data is less than 2. Is that a right statement? 90% of this data
Yes, sir.
Yes.
is less than 2.
Yes, sir.
Yes, sir.
Mean is 2.5. Is that a right statement? When I calculate the mean, I got 2.5 as the mean. 91 side, I'm saying 90% of the data is less than 2. Other side, I'm saying mean is 2.5. Don't you think these two statements are contradictory?
Yes, sir. Of course.
Yeah.
Yes,
On one side, I'm saying 90% of the data is less than 2. On the other side, I'm saying mean is 2.5. Why this contradiction happened? What is the reason for this contradiction?
because of outlier.
Outlier.
Because of outliers. When there are outliers present in the data, you cannot really trust the mean value. Mean is no more the true center. Then what we should do? We should calculate a new measure called median. Median is also an average value. It is an alternative to mean. However, median is not impacted by outliers. How do you calculate median? You take the data, then you sort the data. So this is the sorted data. Take the original data, sort the data, take the middle value. This is called median. So for the same data, mean is 2.5, but median is 1.4 only. Mean is the true center. I have a question here. Instead of 9, if I have 99 here, 9 is not the outlier, 99, very large number. What will be my new median? Will it be 1.4 or 14?
1.4.
1.4.
Even instead of 9, if I have 99 also, still the center value is 1.4 only. Instead of 99, if I have 999, instead of 99, if I have 999, what is the new median?
1.4.
1.4.
Still
1.4.
Can I say median is not impacted by?
Outlier.
Median is not impacted by?
Outlier.
Outliers.
So previously for the capital gain, you told the mean value is 1077. Can I directly trust this on the face of it? Can I think that always the capital gain middle value is 1077? Can I trust this just by looking at the mean? Are you going to do this in future? Can you simply
No, sir.
calculate the
No,
mean
sir.
and think that that is the center? Is that a good option?
No, sir.
Not at all. When can I trust this? I can calculate the mean value now. I can calculate the median. If the median value is somewhere around 1000, somewhere around 1100 or 1200, somewhere around near that, then I would say this is the center. If mean and median are far away from each other, what does that mean? For a variable, you calculated the mean, you calculated the median, then they are far away from each other. Very different. What that could mean?
Outlier is there.
There are outliers.
There are some outliers. That is our first hint. And outliers are very important for detection and elimination. We are going to talk a lot about the outliers in the upcoming slides. Can you quickly calculate the median and tell me for capital gain for the same variable?
Zero point.
0.5.
Let's wait for everyone to complete this. By any chance, if somebody is lagging behind because the code is not working, system is not opening, something is wrong, quickly stop me, send me a message. I'll make sure that I'll bring you onto the up the pace with everyone else. The median value is how much? 0. What? Mean capital gain is 1000. Median capital gain is 0. As a data scientist, what do you infer from here? What does this tell you? What is this trying to tell you?
There are some
Mean.
outliers.
There are
Negative
outliers.
values.
There may be presence of outliers for sure. Maybe negative values are there. That is another inference we can make. But what is the major inference? Mean is 1077. Median is 0. What does that mean? There are outliers present in this data. Make a note of this. We are going to revisit outliers once again. Okay. As of now, you can think this as a hint, but there is a proper way of finding out the outliers, detecting what percent are outliers. We're going to look at that soon. That is the story of the measures of central tendencies. I'll pause here and take questions from you. Any questions here until whatever we discussed?
So even the median is not a very good measure of getting into the central tendency, right? The central value, the way, because it is not getting affected with the different range of values.
What does that mean?
Means, let's say after 1.4 we have values like 99, then 200, 300, 400. Still the value is gonna remain 1.4.
The center value, median is the true center. Like if you look at the center, that will be the median. Let's say if you are saying after 1.9 everything is higher than 1.4. Okay, even if you say 99 and like 200 or something, in that the center within the given range, whatever is the center, that is your median. Okay, what you're assuming is you're assuming only one or two values here. You have to also assume the complete data, right? No matter which is the data that you take to arrive at the median, what is the formula that we are using? Simply sort the data, take the center value. In the given data set, that happens to be the center. Okay.
So 50% is correct.
50% of the data is below this, for sure. 50% of the data is above this. That is for sure. No matter what is the range of your data, no matter what is your minimum value, no matter what is your maximum value, I can give guarantee that 50% of the data is this side, 50% of the data is this side. The calculation of the median is such that. Okay.
Okay, I got it now.
If we have even number of data, then
let us suppose there are 10 data points. Here, luckily, or simply to make this conversation very simple, I took 11 records and then I took the 6th record as the median value, isn't it? What if there are 12 records? Then what we do is we take the average of the middle two as the median. Okay. If you have even number of records, take the middle two records. Let's say if you have 12 records, right now how many are there? 5 plus 5, 10 plus 1, 11 are there. What if you have 12 records? Take the 6th and 7th record, take the average of that. That will be your median. Okay. Clear?
yes, sir.
Sir, Sabisati here.
Yeah.
Sir, suppose we have 10 data and out of 10, 5 are we can call them 5 data we have out. Means we can call them as big numbers, like we can call them as outliers, and 5 are like less than 1.
Right.
So in this case, can you tell there are outliers or?
What we can tell is, like, since a large portion is there, usually when we say outliers, people have a tendency to think they are a smaller portion in size and very distinct from the rest of the values. But what you're saying is, it looks like a common pattern. 50% of the data is in certain range, let's say in thousands. 50% of the data is in certain range, let's say in tens. Okay. Then what we can say is this data consists of two distinct subsets of the population. Let's say if you say income, okay, let's say this is income variable. There are a 50% of the population who are earning only in hundreds. There are 50% of the population who are earning in thousands. So we can say, we cannot say outlier or anything. What we can say is, these are two different sets of data, two different subset of the data in the whole population. Because from these guys point of view, these are outliers. From these guys point of view, these are outliers. Always high side outliers we cannot say, right? Like sometimes low side outliers are also possible. So we can say these are not outliers. Seriously, these are kind of two distinct type of subsets. Let us start a story. Let us suppose there is a person, he wants to cross a river, but he doesn't know how to swim. If he starts crossing, he may drown. He has to go from here to here. So there is another person who is standing by the side of the river. He asked him, what is the depth of the river? This person, he told the average depth is 4 feet. This person is very smart. He asked him, don't tell me the mean depth, give me the median depth, because I just completed this mean and median. This person told, don't worry, median is also 4 feet. Mean is also 4 feet, median is also 4 feet. This person is around 6 feet tall. He starts crossing the river. Can you guess what has happened after some time? Can he reach here, or was it a sad story where he drowned? What do you think would have happened?
Brown, sir.
Third story.
No.
Yeah,
Story.
there's a
Yes,
high
it's not-
chance that it's not going to be a happy ending story. It's going to be a sad ending story, isn't it? Why? Because average depth of 4 feet doesn't necessarily mean everywhere it will be exactly 4 feet. Sometimes the depth may be just 1 feet, 2 feet, 3 feet, less than 4 feet, isn't it? Sometimes the depth is 6 feet, 7 feet, 8 feet, 9 feet, 10 feet, more than 4 feet. Middle value 4 doesn't necessarily mean around 4, everything will be exactly 4, everywhere it will be 4, 4, 4, 4. That will not happen. Looking at the center, we will not get any idea on the spread of the data. Looking at the center, you cannot get the idea on the spread of the data. Around the center, how data is spread, that you cannot get. There has to be a different measure for the dispersion in the data. What do you mean by dispersion? Let us see. Let us suppose you have two companies, company A, company B. When you look at their results, the profit after tax in the last 3 years for company A is around $15 million. For company B also $15 million profit after tax. Both of them are giving the same average profit after the tax. I mean, simple profit. These are the profits by company A. These are the average profits by company B. If I want to invest in a long-term, less risky company, I want to invest for a long term in a less risky company. Which company should I invest in? Is it A or B? If I ask that question, by looking at this, we will not be able to make a proper decision because both of them have the same average. However, if I give you the real data, company A, $15 million profit. Company B, $15 million profit. I want to invest in a company that is very less risky. I want to invest in a company for a long time. I want to be safe. Which company is better, or both of them same? Because 15, both of them same. Don't worry. Is that the case? Think about it, all of you. Put that in the chat window. Think about it. Yeah. Is it company A or is it company B? Tell me in the chat window. Everybody unanimously, all of you are giving me the answer B, 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 B. What is that which made you choose B? The reason is you thought B is giving consistently around 15. So for a less risky company, one of the more, what is a certain feature of a less risky company? They're always consistent. So company A, company B, they have the same middle value, mean value is same. However, for company A, sometimes the profit is way above $15 million, 43, 44, like that. For company A, sometimes the profit is way below 15, sometimes even the losses were there. Loss, isn't it? Agreed or not? Though the average is 15, but company A has more spread in the data, whereas company B precisely always around 15. Always it is around 15. For company B, there is less spread in the data. However, by looking at the mean value, I cannot get an idea on the spread because mean is same for both the companies. To really quantify the spread in the data, there has to be a new measure. That is known as measure of dispersion. Dispersion means spread. Measure of dispersion. What is the spread in A? Higher spread. What is the spread in B? Lower spread. Or lower dispersion in B, higher dispersion in A. How do you quantify? How do you give a number? A has higher number, B has higher number. How do you quantify it? Using a measure called variance. Variance is a measure of dispersion. How variance is calculated? Take the original data xi values. These are the values. Take the mean x bar 15. Take the mean x bar, which is 15. Okay. Then value minus mean, value minus mean, value minus mean, 43 minus 15, 28, 44 minus 15, 29, 0 minus 15 minus 15. These are all the values. Value minus mean. This is also deviation from mean. Some of them are positively deviated, some of them are negatively deviated. Whereas if you come to company B, these are the deviations. Again, some of them are positively deviated, some of them are negatively deviated. Tell me one thing, if this deviation from mean is higher, does that mean dispersion is higher? Think about it. If the deviation from this mean, if these values are high, does that tell me the dispersion is high? Is that a good indication? Yeah, makes
Yes.
sense. If these deviations are higher, then my dispersion is high. Agreed or not? Yeah.
Yes.
Now, I cannot simply take the summation of all these deviations. No. I cannot take the summation because some deviations are positive, some deviations are negative. Few deviations are positive, few deviations are negative. Just simple summation is not a good idea. Either I have to take absolute value, then take the summation or the average, or I have to take the square value. So here square is mathematically convenient. So xi minus x bar whole square is taken. This is 28 square, 29 square minus 15 square. No matter whether it is positive or negative, square value will be always positive. Take the average of all these square deviations. How do you find average? Sum divided by count. That is variance. What is variance? Look at this. Xi minus x bar whole square. All of you must follow this formula now. It is easy, isn't it? Now that notations are known. Xi value minus x bar mean whole square. Why are you squaring? Because some of them are positive, some of them are negative. Find the mean of all such squared deviations. That is variance. In this course, whenever you see a formula, you do not need to memorize it. No need to memorize any of the formulas. However, we have to understand, but memorization of the formulas is not required. It's good to understand, that's it. Okay. Variance for company A is 352. Variance for company B is 4.9. So apart from giving the mean value, if I would have given you variance for company A 352, variance for company B is 4.9. If I ask you this question, I am looking for a short term. I'm looking for a short term investment. I want to invest now. I want to sell by the end of the month. I want to buy today. I want to sell by the end of the week. I'm a short term trader. I'm not even an investor. Then which company should I choose? The company with higher variance or the company with lower variance? What do you think is beneficial for my trading activities? Company with higher variance or company with lower variance? Obviously, the company with higher variance. If I'm looking for a long-term, less risky company, I'll take the company with low variance. Variance will quantify the dispersion in the data. What do you mean by dispersion? From the mean, how my data is varying. This is my center. How my data is varying, how my data is clustered around the center. Is my data always near the mean or my data going far away from the mean? That is what is going to be given by the variance. The only counterintuitive point here is everything looks to be highly squared up. Okay, we are kind of giving a very highly inflated value. What do we do is we can take the square root of variance. We can also use this measure. This is an extra measure which is known as standard deviation. Either we can use variance or we can use standard deviation. Both are one and the same. One is just the square root of other. So both variance and standard deviation, they quantify the dispersion in the data. Higher the variance, higher the dispersion. Lower the variance, consistency is there in the data. In some cases, I think you may have observed this, there are some cases where you want high variance. Agreed or not? There are some cases, there are some business cases where you want low variance. Okay. It's not that always high variance is good. It's not that always low variance is good. Depending on the business problem that is in your hand, you may have to decide which one is more beneficial for you. Do you want versatility? Then go for high variance. Do you want consistency? Go for low variance. That is the story of variance. It is used for measuring the dispersion in the data. By dispersion, I mean to say how the data is spread around the mean. Around mean, how is my data spread? Higher spread or lower spread? If you have outliers in the data, automatically the variance will be high or low. If you have outliers in the data, automatically variance will be, let's say full data is here for B, but there is one point that is here. Automatically the variance will be high. So usually outliers is a big headache. We are also going to see how to clean the data when there are outliers, that is upcoming. Okay. So the question is, I have a question. Are these the backbone of data science? यार ये question तो बहुत ही generic है. कैसे answer करो? Yes भी correct answer है, no भी correct answer है. But whatever these are, we have to learn this. Let's go that way. Okay. अगर वो backbone है या फिर front bone है या rib cage है, कोई भी चलेगा. Okay. I would say these are important to understand the rest of the algorithms. Okay. Or do you want to rephrase the question? You want to ask, intend to ask something else, is it? You got it? Yeah. मतलब कोई भी है, like whatever it is, like basically what I can say is these are very important to understand the upcoming algorithms. Good understanding is very important here. Okay.
So one query.
Yeah, go ahead, Amit.
Yeah. How mathematically value minus mean square defines the variance mathematically in terms of mathematical terms?
Mathematical term. So basically what is variance? Dispersion. Okay. What is dispersion? The deviation from the mean, isn't it? So that's what that is. So that is why we are taking the deviation from the mean. But the problem with the deviation from the mean is if I simply want to take the average deviation from the mean, imagine, okay, to find the average, I have to find the sum. While finding the sum, this may cancel out, this may cancel out, positive values, negative values may cancel out. Either I have to take the absolute value or I have to take the square value. So that is why we are taking the square of the value. Usually absolute is not a mathematically convenient function, the derivative and all that. That is why we take the square. So it is capturing the dispersion by taking the deviation square and average squared deviation, which is nothing but the dispersion.
Right.
Yeah. And the other question is where to use variance, where to use standard deviation. Both are one and the same. These are not two different measures that at some places you have to use only variance, at some places you have to use only standard deviation. There is nothing like that. Both are one and the same. Tell me, if variance is 25, what is standard deviation? 5. Let's say for a different variable, variance is 100. What is its standard deviation?
10.
10. That means if variance is high, standard deviation is also high.
Yes, sir.
Variance is low, standard deviation is also low. That means if variance is low, we will say consistent. If variance is high, we will say inconsistent. Same thing, you can make the same conclusion by looking at standard deviation also. But the only difference is variance, we have to be careful. It is a squared measure. Let's say if the units are in dollars, variance unit, strictly speaking, that is dollar square. If the units are in kgs, variance will be kg square. Sometimes we are not comfortable in giving these kind of units, then we can talk in terms of standard deviation. Otherwise, analysis wise, inference wise, final result wise, they both tell us the same story. Okay. Any connected questions? Now what I want you to do is import this data set called online retail sales data. Online retail sales data. There are two columns, unit price and quantity. Tell me what are the variance and standard deviation for unit price and quantity. Go ahead, all of you. What are the variance and standard deviation for both unit price and quantity? These are for quantity, is it? All right. So try to put what exactly are you referring to? Unit price. First tell me unit price, variance and standard deviation. Unit price, variance and standard deviation. Unit price. Quantity is 83,695 and then 289. Variance, standard deviation, they themselves, they may not help us in building a strategy. They may not give us a complete conclusion on the data. These are very, very simple measures. They are used for data exploration. You explore the data. They are used for understanding the data. They are used for understanding the data. But usually these simple measures are not used in decision making. Decision making or strategy making. These simple measures are not used. These are used to just understand the data, because this is just a simple measure. We have to do a lot of other analysis to build a strategy. Do you agree with me? A simple measure like variance or simple measure like standard deviation or a mean may not be used completely just to build a single strategy in the business. Yes or no? These are useful for understanding your data. You have to analyze the data further and further, further and further. Finally, you build a strategy. All right. Now the next part of the story. Imagine, by the way, all of you, are you done with this exercise? Any issues with this exercise while you are doing it? Anybody facing any issues? Jyoti, what is the issue that you're facing? No issues? Perfect. Done with this? Okay. Okay, no issues. Perfect. This is pretty straightforward. We haven't yet entered the real complicated techniques or anything. These are fairly simple to understand. Some of you already have the experience of using them, or at least you have the intuition to understand this, because most of you might have worked on similar terms. It is a different place. Let's start the next story. Imagine there is a student who attempted an exam. Along with him, there are 10,000 other students. Overall, 10,000 students attempted that exam. This person got 80 out of 100 marks. Is he doing a good job? Somebody got 80 out of 100 marks. Is he doing a good job? What do we say? Somebody told I got 80 out of 100. 10,000 people have attempted this exam. Is he doing a good job? What do you think? Looks like he's doing a good job. Getting 80 out of 100 is not a small thing. However, there are two scenarios, mind you. Scenario one, sometimes we can't say that is true. Scenario one is with 80 marks, he may have outscored 9,000 people. Only 1,000 people outscored him. That means 90% of the people are below him. Only 10% are above him. With 80 marks, he is standing at 90 percentile. Then he is doing a good job, no doubt about it. Yes or no? In
Sir,
scenario two.
Sir, I couldn't get, sir.
Okay. Until here, is it clear? Somebody attempted an exam. Okay. He got 80 out of 100 marks. Is he doing a good job or not? Until there, was it clear?
Yes, sir.
So that was a discussion that we are having. Like, somebody got 80 marks. Is he doing a good job or not? Most of the times it looks he is doing a good job. But you know what? There are some peculiar scenarios. Even when you get 80 marks, you may not be doing a good job. For example, let us take one scenario. Scenario one. He got 80 marks. With 80 marks, he outscored 9,000 people, which means 9,000 people got below 80 marks. Only 1,000 people got above 80 marks. 90% of the people got below 80 marks. Only 10% have got above 80 marks. That means where is he standing at? Which percentile he is standing at? 90% got below him. Only 10% got above him. This person is standing at
90%.
90 percentile. If he is standing at 90 percentile, if with 80 marks he stands in scenario one, then I would say he's doing a good job. If this is the scenario, then he is doing a good job. Because he's standing at 90 percentile. 90% of the people scored less than 80 marks. He's doing a good job, isn't it? Yes or no?
Yes, sir.
But in scenario two, in a different scenario, he got 80. But below him, there are only 500 people. Above him, 9,500 people are there. The paper was so easy. It was already leaked. Everybody knew the answers. 9,500 people got above 80 marks. Only 5% of the people got below 80. 95% people got above 80. Only 5% got below 80. Which percentile he is standing at now?
5%.
5 percentile. Is it possible or it is impossible? Never in this world, it will never happen. Can we say like that, or is it possible this scenario also?
Possible.
It's possible. So always looking at 80 out of 100. See, he got 80 out of 100 here. Can he say he's doing a good job here? He got 80 out of 100. Come to scenario 2. Is he doing a good job?
No, sir. No, sir.
Though he got 80 out of 100, but only he could outscore 5% of the people. He's standing at the 5 percentile. We would say he needs a lot of improvement, isn't it? If it is scenario 1, if you are standing at 90 percentile, below you 90% of the data is there, then you're doing a good job. But below you only 5% of the data is there, 5% of the population, then you're not doing a good job. Sometimes looking at the standalone number 80, you will not be able to decide, or looking at the standalone number X, you will not be able to decide whether X is a higher number or whether X is a lower number. You have to compare it with the rest of the population. Do you agree? And look at the relative position of the X to decide whether it is a higher number or lower number. Once again, sometimes just by looking at the standalone number, you will not be able to make the final decision. You may have to compare and check where exactly X stands when you compare with the rest of the population. Agreed?
Yes, sir.
Yeah. So comparison of a particular value with the rest of the population is done using percentiles. What is a percentile? X is the original value. The percentile of X may be different. You take the minimum value, you take the maximum value. And if X stands here, below X there is 20% of the data, above X there is 80% of the data, then which percentile X stands at?
20%.
20 percentile. Do you agree with that point? Below me, how much ever is there, that I have to check. In a different example, this is the minimum value, this is the maximum value. Above X, there is 20% of the data. Below X, there is 80% of the data. Then X is standing at
80%.
80 percentile. So what is a percentile? For any given value X, percentile will tell me what is the relative position. Specifically, below X, what percentile of the data, what percent of the data is there? Above X, what percent of the data is there? That is given by the percentile value. That is useful for knowing the relative position. Which one is better? Telling you that I got 80 out of 100, or telling you that I got 90 percentile or 5 percentile? Which one will be help you to make the better decision? Where can you take better informed decision? By knowing the percentile or by knowing the actual value?
Percentile.
That is the reason why some of the universities, some of the exams, they don't care about the original marks. They always tell you the percentiles. Do you agree with that point? Why? Percentiles will tell you the relative position. No matter what marks you got, I don't care, isn't it? Some exams, no, we don't care about the marks. I got X marks. I don't care. With X marks, where do I stand? Below me, what percent? Above me, what percent? That's what matters. Percentiles are not only used in exams, it can be used in some other statistical measures as well. Percentiles are very useful in our day-to-day data science life as well. We are going to discuss percentiles in depth. How do you calculate percentiles in Python? How to interpret the output, etc., etc. So in Python, how percentiles work? Percentiles are calculated for any numerical variable. If you take any numerical variable like income, exam score is anyway there. Okay, that is a usual example. But in general, percentiles can be calculated for any numerical variable: income, age, expenses, okay, or number of loans, like that, any numerical variable. What you need to do is you need to tell the percentile value, what percentile you want. You need to give this to Python. Then the variable value will be given to you in the output. Variable value. The variable can be income, income corresponding value. Variable can be age, age corresponding value, expenses corresponding value. You can give the data. Let's say I have given income data as input. You can ask for 0 percentile, you can ask for 10 percentile, you can ask for 20 percentile, you can ask for 30 percentile, you can ask for 50 percentile, you can ask for 60, 80, 70, anything you want. 80, 90 percentile, 100 percentile also. Tell me one thing. If you ask for 0 percentile, what will Python give you in return? It will arrange the data in the descending order from maximum to minimum. It has to find a point where below that point 0% of the data is there, above that point full data is there. What will be the result for you if you ask for 0 percentile?
0.
0.
Is it always 0 for sure, pakka? Below that point nothing is there, above that point everything is there. What is a 0 percentile value? Think about it carefully. Is it always 0? When you ask for 0 percentile, or let me give you a different example. If you ask for 10 percentile, Python will find a point where below that point 10% of the data is there, above that point 90% of the data is there. Exactly that point will be given to you. If you ask for 0 percentile, what Python will give you? It will find a point below that point 0%, above that point everything. It will give you what value? Minimum value of that variable. Do you agree with that point? If you ask for 0 percentile, there is a particular point where that below point there is nothing, everything is above that. That means that is the minimum value. Agreed or not? Make sense?
Can you repeat?
Think about it. You asked for 0 percentile. You asked for 0 percentile. What is 0 percentile? That particular point in the data, below that point there is nothing. Above that point full data is there. What is that point? You take any data. What is that point where below it there is nothing? Can I say that is the minimum value? The minimum, below
Right.
minimum value, there will be nothing, right? There will be nobody whose income is less than minimum. Yes or no?
Right.
So if 0 percentile means the minimum value, makes sense?
Right.
Yes.
Right.
Similarly, if I ask for 100 percentile, Python has to find me a point where below it is 100% of the data is there. Python has to search. Python has to go to this variable, let's say income. Search for a point below it, 100% of the data is there, and nothing is above that. What is that point? Tell me. If you take any variable, below it
Max
full
value.
100% of the data is the max value. Look at this, all of you. Mean and max values can be called as 0 percentile and 100 percentile. Think about it carefully once again. 0 percentile is the minimum value. 100 percentile is the maximum value. We also discussed one more percentile in this list with a different name. We discussed in this list. Look at this list carefully. 10, 20, 30, 40, 50, 60, 70, 80, 90. We discussed one more percentile, a particular point. Can you tell me what other percentile we discussed? What other percentile in this list? Think about it carefully. Try to recollect it. What other percentile we discussed here? What other percentile? Is it 10 percentile that we discussed with a different name earlier? Is it 20 percentile that we discussed with a different name earlier?
50%.
We discussed 50 percentile. There is a point where 50% is below it, 50% is above it. Can you tell me that point? What is the 50 percentile point? Exactly middle point, 50% below, 50% above. Is it mean? Is it mean? Are you sure? 100% sure? Or median?
It's medium.
50 percentile is mean, is it? It has to be median, isn't it? Is mean always 50 percentile? Is there any guarantee? No, mean is not the one. Median. Similarly, if you ask for 10 percentile, Python will arrange the data in the descending order from max to min. It will find a point below it 10% is there, above it 90% is there. It will be given to you here. If you ask for 20 percentile, Python will find a point below it 20%, above it 80%, that will be given to you here. If you ask for a point 30 percentile, have you understood what is happening in the background? Python will arrange the data from max to min, find a particular point where below it 30%, above it 50%, above it 70%, like that. Then we will be analyzing this data. Then we'll be understanding this particular variable in depth, whichever variable that we are giving. Tell me one thing. Let us suppose somebody got 90 marks out of 100 marks. Is it still possible for him to end up in 60 percentile? Or it is impossible? ऐसा कभी होगा ही नहीं है.
Yes, sir. Possible.
Yes.
Possible, right? It's possible. You cannot dictate that 90 marks means always I should get 90 percentile. No. When it is possible, only 60% I have got above below 90, isn't it? But remaining 40% got above 90. Then even with 90 marks, I can end up in 60 percentile. Do you agree with this point? All of you think about it carefully.
Yes.
Does it make sense? Yeah. On the other way, contrary to this, is it possible that I got 60 out of 100 marks only? Can I still end up in 95 percentile? Is it possible theoretically?
Yes, possible.
Possible. 60 means always 60 percentile only, or the number and the value, they are not connected, isn't it? This is relative position based on the population. This is the original value. It's all relative. 60 marks, still 95 percentile. When it happened, 95% of the people who got less than 65 marks, 60 marks, only 5% have got more than 60 marks. Okay. When the exam is really tough, it may happen. Now what I want you to do here is, as an exercise, go to the capital gain, that variable. Find the percentile values. How do we find the percentile values? Write the data frame name, column name. Quantile is the function, Quantile, and give the percentile value, 0 percentile, 10 percentile, 20 percentile, 30 percentile. 0 percentile means what? Minimum value, 40, 50, 60, 70, 80, 90 percentile, 100 percentile, which is maximum value. Get these values, and what will you have in the output? You will have a table in the output. First one will be percentiles. The second one will be capital gain, corresponding capital gain values. This will be the result that you will have. The percentiles will be whatever percentiles that you have given, 0 percentile, 10 percentile, 20 percentile, 30, 40, 50 percentile, 60, 70, 80 percentile, 90 percentile, 100 percentile is what you will get. And the percentile corresponding values. Get this output. We will now discuss that output here. You got the output, all of you. All right. Are we ready to discuss now the output? Now, 0 percentile value is 0. Yeah, looks like somebody has a question. Yeah, go ahead. Zero percentile value is 0, which means what can I say by looking at this? Minimum value of capital gain is
0.
0. There is nothing less than 0. Is that a right statement? When you see 0 percentile, will you be able to write this? Whichever
Yes.
is the variable. 0 percentile means whatever is the value, that is the minimum value of that variable. 10 percentile value. How much is that 10 percentile value? 0 in your case. From here, I can make two statements. Statement number 1 is 10% of capital gain is less than or equal to 0 for sure. Agreed? Look at that statement. 10% of capital gain is less than or equal to 0. If 10 percentile value is something, then we can say 10% of the capital gain, this variable is less than or equal to 0 for sure. In this case, it is actually equal to 0. But less than or equal to covers both. Is it a right statement? Confirm that to me. 10 percentile value is 0. From there, I am making the statement. 10% of capital gain is less than or equal to 0. Make sense?
Can it be less than?
Is this a right statement? 10% of capital gain is less than or equal to 0. In this particular case, it is actually equal to 0. If you want to write it in generalized form, you will write like this. Yes or no? Let's say if 10 percentile is 2, then you will say 10% of the capital gain is less than or equal to 2, like that, isn't it? So since it is 0 here, you will say it is less than or equal to 0. Look at that statement carefully, all of you. Does that make sense? Is that a correct statement? Let's say if 10 percentile value is 15, I would say 10% of capital gain is less than or equal to 15. 10% of the times capital gain values, you'll find less than or equal to 15. But here it is 0. So less than or equal to covers both. What is the second statement? Maybe. So I'm trying to keep all of you mute then, because there is a little bit of background noise that is coming. Okay. Okay. Maybe remaining 90% is greater than 0, but this I'm not sure. I cannot make a comment by looking at the 10 percentile value. I cannot make a comment about the remaining 90%, that 90% will be definitely greater than 0. Maybe 90%, maybe 20%, maybe 30%, maybe 80%, maybe 15%, maybe greater than 0. But this one I cannot make a comment. That's why I'm not sure. Do you agree with the second statement as well? Maybe the remaining 90% is greater than 0. But yeah, this one I'm not sure. Agreed or not? Yeah. 20 percentile value is 0 in this case, which means 20% of capital gain is less than or equal to 0 for sure. Is that a right statement? Looking at the 20 percentile value, I can say 20% of the capital gain is less than or equal to 0 for sure. Why are you so sure? I have seen the minimum value, I have seen the 10 percentile value, I have seen the 20 percentile value. Until now, I have seen everything clearly. I can make a comment, solid statement on this. 20% of the times capital gain is less than or equal to 0 for sure. Maybe remaining 80% is greater than 0, but is this sure? Am I sure about the rest of the 80%? Have I really seen it? Can I really make a comment on the rest of the 80%? This one you cannot make a comment. So not sure. Are you understanding why I am writing not sure about the rest of the 80%? Because we haven't seen it. Similarly, you can see 30, 40, 50, 60, 80 percentile is 0. Tell me the first statement, all of you. If 80 percentile is 0, what is your first statement? Put that in the chat window. If 80 percentile is 0, what is going to be our first statement? What is going to be our first statement? 80% of capital gain is less than equal to 0 for sure. Right? What is the second statement? Maybe the remaining 20% is greater than 0. But am I so sure about it? Have I seen it? Can I make a comment on this? Can I be so sure about it? Nope, not sure. I'm not sure. Up there, all of you are out there, like just two more. Let's go ahead. 90 percentile is 0. What is our first statement? What is our first statement? 90 percentile is 0. What is going to be our first statement? %90 of capital gain is less than equal to 0 for sure. Hey, why are you so sure? How can you be so sure? Because I have seen from minimum to 10 to 20 to 30 to 40. Have we really clearly read completely until 90% of the data? Have we understood until 90%? Have we seen it? What is there to understand? Everything is 0, 0, 0, 0 only. 90% of the data is 0. We got a good clarity on that. Yes or no? Agreed or not? 90% of the data is less than or equal to 0. In this case, it is actually 0 for sure. Tell me the next statement. What is the next statement? At this juncture, looking at this value, what can I talk about the future? Maybe remaining 10% is greater than 0. But are you so sure? Looking at this without knowing what is the next one, can I make a comment? This is not sure. What is the 100 percentile, which is the maximum value? How much is that? Maximum value of the capital gain. Maximum value of the capital gain. How much? 100 percentile maximum value 99999. Is it fair to conclude that 90% of the data is 0? 10% of the data is definitely greater than 0, which is positive. Can we conclude like this? Is it fair to conclude like this? Is it a right statement? Or there is a chance that even less than 10% of the data, even 10% is also not greater than 0. Can I conclude like this? Is it fair to conclude like this? Think about it. Or it may happen that 95% are zeros, maybe 5% is non-zero. Or it may happen that 93% are zeros, 7% is non-zero. Or it may even happen that 99% are zeros, 1% is non-zero. Just that I haven't seen the last 10 percentile. Can I assume this? Is it a right statement? Look at this, all of you. Is this a right statement? 100% accurate statement? Is this one? Can I be so sure about this statement? No. Then what should I do to understand? I understood 90% of the data perfectly. I am very confident about this. All of you, do you agree with me? 90% of the data, check. Perfectly understood. What should we drill down now? What we should drill down? From 90 to 100%. We should drill down to understand further. Make sense? We should drill it down. Shall we drill down? How do you drill down? How do you get 91 percentile, 92 percentile, 93 percentile? How do you do that? Here is the process. Like the way you have 10, 20, 30, 40 and all that. So how do you get 91 percentile? 0.9 is 90 percentile. 91, 92, 93, 94, 95, 96, 97, 98, 99, 100 percentile. I want you to look at this output. I don't want you to paste the output in the chat window, but answer this question. Finally, what answer I want from you? Simple 2-line answer. What percent of the data is 0 in capital gain? Simple. I want you to analyze the output by yourself and answer this question. What percent of capital gain is 0 and what percent is non-zero? That's what I want you to tell me. Look at the output. Finally, don't paste the output in the chat window. That's not useful. What percent of capital gain eventually is 0? What percent of capital gain is greater than 0? Tell me this percentage, this percentage. These are the 2 lines of answer that I want to look into every message. What percent of the capital gain is 0 for sure? Eventually, what percent of the capital gain is 0? What percent is non-zero? Let me also do it. %91 is 0. Remaining 9% is non-zero. Strictly speaking, maybe 91.5, maybe 8.5, something like that may come, but roughly we can roughly round it off to 91% and 9%. This way, by looking at the percentile values using the function quantile, you will be able to understand the variable completely from minimum to maximum. Completely, you will be able to strip down the variable, completely understand the variable. This is known as distribution of a variable. Distribution of a variable. What do you mean by distribution of a variable? Within its limits, from its maximum to minimum. From its minimum to maximum. What are the values it takes? Where is the concentration of the variable? You will get to know that by looking at the complete percentile distribution from minimum to maximum. You can totally understand by looking at these percentile values. By combining this percentile distribution with the business context, you will be able to easily detect the outliers. How do you detect outliers? By looking at the percentile distribution plus the business context. What do you mean by business context? We take this result to our business partner, our client. We tell him that capital gain, you know what, 91% of the times it is 0 only. Only 9% of the cases it is greater than 0. That's what we found. Acknowledge that. Capital gain, 91% of the times it is 0. 9% of the times it is greater than 0. That's what we found. Then our business partner will tell the business logic to us. He will validate this first. He will say, yes, you are right. This is supposed to happen. In fact, capital gain has to be 0 always. Always it has to be 0. Any negative values, any greater than 0 values, these are all erroneous values or outliers. This is what the business partner is telling us. According to the business logic, which we don't get to know by looking at the data, we have to understand the underlying business logic. According to underlying business logic, capital gain has to be 0 always. But if it is negative or greater than 0, then there is an issue. So what percent of the data is clean? What percent of the data is having issues with respect to capital gain? Tell me. With respect to capital gain, What percent of the data is clean? With respect to capital gain, 91% of the data is clean. With respect to capital gain, 9% of the data has issues in this column. These 9% issues are erroneous or outliers like this. You can detect the outliers by looking at the whole distribution of the percentiles. And is it just that you will use for detection of the outliers? No, plus the business context. This is something that a lot of people miss. We always need to consider the underlying business context. Based on that, we have to decide what are the final outliers. So detect the outliers, we have to look from minimum to maximum. What we will do now is to understand this further, we will take a real data set. In that real data set, we will take a real column, a large data set and a column. We'll try to detect the outliers. Let us see whether we can do it by ourselves. Okay. I'll give you the business context in that data set, because always first we need to understand the underlying business. So here is the data set. This is one of the credit risk model. There was a competition on Kaggle that was run by a bank. If you click on that link, this competition name is Give Me Some Credit. We have to build a credit risk model and the prize money was $5,000. However, in here, we are not building a credit risk model. We are preparing data, we are exploring data before building that credit risk model. Okay. We will import this data and there are several columns. We'll focus on one of the columns from there. Okay. Import this data set. Print all the columns. Focus on the column monthly utilization. First import the data set. Once you have the data in front of you, send me a message. Then I'll give you the business context. Monthly utilization. Customer is good customer or bad customer, we may use several features or several factors. The idea is not to build a model right now. The model building will happen later on. That we'll be discussing at later point. Here, there is one column called monthly utilization. We need to find out, we need to explore this variable, explore, understand. And if there are any outliers, we need to detect them. That is the responsibility right now. Monthly utilization is a percentage value. Monthly utilization percentage. Let us suppose customer A, he has 1 lakh credit limit. Every month he is utilizing, let's say 95,000, 96,000, 98,000, like that. On an average, he is utilizing 95,000 every month. So his utilization percentage is 0.95 or 95%. Customer B has 1 lakh credit limit, but every month he's 5 for 10,000 or 15,000, 15, 20, something like that. So his utilization percentage, he uses 15,000 out of 1 lakh. His utilization percentage is 0.15, which is 15%. For a financial institute, who is risky? A customer who is swiping a lot, who is spending a lot, is customer A risky? Or a person who is utilizing the limited amount, is he risky? Think about it. Always the person who is spending a lot, monthly utilization, if that is high, they are considered as risky. Now, this is one of the important variable when it comes to deciding the risk associated with the person. Even our credit score also considers monthly utilization as one of the important variable. in India? Do you know what is our credit bureau in India? Where do you get your credit score from?
Civil.
CIBIL. If you log into your CIBIL, I think it is not free. You have to pay some amount, isn't it? If you log into your CIBIL, there also you will see monthly utilization percentage as one of the variable, and the monthly utilization percentage has to be lower for you to get a good CIBIL score. If the utilization percentage is high, your score will also go wrong. That means while you are taking loans, we need to be careful. If the utilization is high, then CIBIL score will be problematic. Now let us see from the business point of view, what are the limits for monthly utilization? Maximum value, minimum value, what are the possible values? It is a percentage value. Tell me what is the minimum value of monthly utilization? Minimum value. Minimum value, how much that could be? Monthly utilization percentage. If a person is not at all swiping, what will be the minimum value? It will be 0%, which corresponds to 0. What could be the maximum value of utilization percentage? Maximum value of utilization percentage. Maximum value could be, no matter what is the credit limit, 100% is the maximum value. 0%, 100% is the maximum value, which is 1. So the limits are 0 to 1. So from the business point of view, the limits must be 0 to 1. Anything less than 0, which means negative values, these are erroneous or outliers. Anything greater than 1, that means if credit limit is 1 lakh, can you swipe for 2 lakhs? Is it possible? Can you swipe for 1.5 lakhs? Is it possible? Will the system allow? Won't you get an error? If you swipe for even 1,05,000 also, you will get an error. So anything greater than 1 is fine. You can utilize the complete amount. 1 is fine. Anything more than 1, that is also errors or outliers. What I want you to do is, you have imported this data, study this variable. Tell me what % of the data is clean with respect to this variable. With respect to this variable, what % of the data is clean? That means between the limits 0 to 1. What % of the data is outliers? That means 2 types of issues, less than 0, greater than 1. What % clean, what % outlier? Study that. Okay. And tell me the answers to these 2 questions. Don't paste the output for me in the chat window. Only answer these 2 questions. Okay. Go ahead, all of you. Try to do it yourself and let me know the answer. I'm writing all the answers from everyone. May be correct, may not be correct. We have to check. We'll discuss the answer anyway. But as of now, I'm just writing down whatever people are telling me. Some people are saying 90% clean, 10% are outliers. Some people are saying 97% clean, 3% are outliers. The other answer is all clean, perfect, 100% clean, which outliers hai nahi. 100% clean, no outliers, 0%. That is also another answer. The other answer is 91% clean, 9% are outliers. Can be right, can be wrong. No need to worry. Some people are saying 99% are clean, 1% are outliers. We will see. Any distinct answer, please let me know. I'm sure you are looking at the output coming to this conclusion. You are not guessing it, isn't it? All of you are looking at the output, doing all the necessary one. 95% are clean, 5% are outliers. When you join a team as a data scientist, this is what you're going to do. There will be a variable. Let's say if you're assisting somebody who is building a model, maybe you may not be able to build the model completely, but at least you will be associate data scientist. Someone else will be building the model. You will be assisting him with this small kind of work. If he gives you a data, if he asks you to find the outliers with respect to a variable, you will be doing this. Getting a data science job is not about clearing the data science interview. It's about learning the data science skill. This is the skill. This is one of the skill. Like that, in 30 classes, you will learn 30 different skills that will give you a good lift in the interview. That's how we should prepare for the interviews, by learning the skill. Let us go through the output now. Monthly utilization, as usual, I look at the complete percentiles. 0 percentile is 0. 0 percentile is 0. That means there are no negative values. Minimum value is 0. 10 percentile is fine, 20 is fine, 30 is fine, 40 is fine, 50 is fine, 60, 70, 80, 90. Until here, everything is fine. 100th percentile is what? Maximum value is 50708. That means 1 lakh is the credit limit. Can I spend 507 crores? Is it possible? If 1 lakh is the credit limit, can we swipe for 507 crores? Will it allow? Will the system allow? So definitely there are some outliers. So that means 100% clean. That is wrong answer for sure. Do you agree with that point? Some of you told 100 and 0. Do you agree here? Why 100% is not clean? There is something wrong here. I can clearly see. The limits are what? What are the limits? 0 to 1. Have we discussed those? Limits are 0 to 1. You can clearly see a number that is way more than 1. 507, 1000, which means like 50,708, which is very, very higher than 1. Definitely this is a wrong answer. Is it fair to conclude that 90% clean, 10% outlier? Just by looking at this, can I conclude right away? 90% clean, full complete, 10% is outliers. Is that the way to conclude? Can we give complete information? Have we really got the complete information? 90% clean, 10%, just like I'll go here earlier, capital gain, 90% clean, 10% outlier. Did we conclude like that here in capital gain? Did we conclude like that? 90% clean, 10% outlier, simply similar to that. 90% clean, 10% outlier. Is that the right way to go about it, or we need to do the drill down? What do you think? Is it fair to say that everything in this 10% will be greater than 1? Without seeing, can we make that conclusion? Or we need to drill down? What do you think? Those of you who told me 90-10, is this a right answer? 90-10, is this a right answer? Can I conclude? Definitely this 10%, everything will be an issue. Or do I need to drill down? We need to drill down. Make sense? Yes or no? Let us drill down. How do you drill down? 0.9, 0.91, 0.92, 93, 94, 95, 96, 97, 98, 99, 90 percentile fine, 91 percentile fine. What did we say? 0 to 1 is fine, 100% utilization is fine, 91 is fine, 92 is fine, 93 is also fine, 94, 95 is also fine, 96, 97, 98, 97, until 97 it's fine. That means maximum utilization, 100% utilization. But if 1 lakh is the credit limit, we cannot swipe for 1 lakh 6,000. If 1 lakh is the credit limit, we cannot swipe for 1 lakh 9,000. So 97% of the data is clean. So 99.1%, you also need to consider this one. These are right values. These are not like really considered as erroneous or outliers. These are also fine. 95.5, I don't know what is the logic, but definitely this is not right answer. 91.9 and all that. So the right answer is 99% of the data is clean because it is the limits. It is within 0 to 1, both included. Greater than 1 is 3%. The final answer would be 97% clean, 3% outliers. Always outliers should be decided based on the data as well as the business context. Business will tell us what are the limits. Data will show us what is the distribution. Based on that, we decide the outliers. Have you now understood how to detect the outliers? Looking at the percentile distribution and detecting, doing the drill down. Yeah. Have you now understood the detection of the outliers, all of you? Will you be able to take any variable in future and detect if there are any outliers in that or not? Yeah. This is a must skill to have, because if there are outliers, so the limits should be 0 to 1. 1 is the maximum value, but in the data we have something like 50,708. If we don't detect the outliers, if we don't clean the data, later on I'm going to show you how to clean the data. If you don't detect, if you don't clean the data, if you take the data as it is, if you take this junk data to the machine learning model, what is the saying? Junk in. No matter how great the model is, if you send the junk data in, what will you get as the output? You will get junk in, junk out, which means you will get all the wrong results. Data exploration, validation, and cleaning is very important. We have now discussed data exploration only. Validation, cleaning, I'm going to show you in a different class. Let me wait here and take the questions. Anybody, any questions on this detection of the outliers? How to deal with fake data? Fake data, so never work on it. Fake data ho hi gaya hai. So if you have fake data, that means model will be fake, everything will be fake. Data, the definition is factual information. Okay. So never start the analysis if we have the fake data. No point in working on something that is unreal, which is not representative of the population. Which means when you are building this model, it should be representative of the population. That is the first assumption. If that itself is fake data, which means not collected information, it is not factual information, then we should never start the model building, or we should not start the analysis. What can be the business context here? Can you give some example? The business context here is build a credit risk model that will predict whether the customer will be delinquent or not delinquent. In simple terms, delinquent means not paying back. Delinquency means what? You have to pay on 30th April. If you do not pay, then you will be called as delinquent. Seriously delinquent means the customer is bad customer versus good customer. Imagine there is a bank, they want to give a loan to the customer. Before giving a loan, they want to predict whether the customer is going to be a good customer or whether the customer is going to be a bad customer. We have to predict it. To predict it, we are taking the customer financial history. What are we gathering? We want to predict whether the customer will be seriously delinquent or not. That means good customer or bad customer. What are we using? We are using customer monthly utilization. Is he utilizing more or less? Customer age, number of times he made late payments, his debt ratio, how much debt he has, how much income he has, monthly income, number of loans already he has, how many times he was 90 days late, 3 months late he paid, number of real estate loans, how many real estate loans, how many home loans that he has, number of dependents, what is his family size. Based on all this, I want to predict whether the customer is going to be a good customer, bad customer. If the customer is going to be a good customer, I'm going to give a loan to him. If he is going to be a bad customer, we will reject his loan application. This is known as credit risk model building. If you have heard of CIBIL score, have you ever heard of CIBIL score? CIBIL score? Okay.
Yes,
CIBIL score is calculated based on a credit risk model. You can think this is the data that is used to calculate the CIBIL score. That is a business context here. Is it clear? All right. Any other questions, anyone?
What is CIBIL score?
Let's say if you apply for a car loan, okay? Or if you have applied for a home loan in India. Sir is muted. You're not able to hear me, is it?
No, we can hear you.
Yeah, okay. Yeah.
I think they were saying that you were muted, everybody.
Okay. So can you, yeah. So what is CIBIL score if you apply for a car loan in India right now? If you apply for a home loan, or even if you apply for any appliance loan, let's say you went to a shop, you bought a refrigerator. Have you ever heard of 0% EMI offers? Or something like if you buy a big fridge or if you buy a washing machine, you can take the loan. You don't need to pay the full amount. Let's say the washing machine is 50,000, but you can take the loan from Bajaj Finserv or somebody. Okay. For you to avail that loan, you should have something called CIBIL score. CIBIL score is the risk quantified score. That means the risk associated with the customer is given in CIBIL score. So in India, before giving a loan, the financial institutes check this CIBIL score. If CIBIL score is high, then you're a good customer. Then you will get a loan very easily. If CIBIL score is low, then you are a bad customer. The companies will not give you the loan. Okay. Any new loan you will not get. That is called CIBIL score. Especially people who already taken the loans, people who already have the work experience, they may have the CIBIL score. Some of you might be students who are yet to open a any financial transaction or anything. What is the chance or what is the risk associated with the customer before giving a loan? Defaulter means you can think that as not paying on time. Serious defaulter means bad customer. That means he will take the loan and he will run away. So if two people come, person A, person B, apply for a loan, there is no guarantee that both of them will be treated the same way. If A has high CIBIL score, he will get the loan easily. If B has low CIBIL score, he will not get the loan. That is what the CIBIL score is. Okay. Does outliers always go away? Data or outlier can be considered as the data with respect to business context. Good question. It always has to be with respect to business context. Let us suppose I'm considering loans portfolio. If I take the variable age, a customer has age of 80, a customer has age of 85, a customer has age of 78. Is it possible for a person who is having age 80, 85, 78, can they be getting the loans? Do you think when a person who is having 78 age or 80 age, 70, 85 age, do you think will they get the loans? Think about it, like normal financial situation, normal any bank or something, will they give these people loans? No. So age of 80, 85, 78, these are outliers from the loans portfolio context, business context. If the business is loans portfolio, these are outliers for sure. Agreed or not? Think about it. Whereas if I'm talking about savings banks, savings bank account or FD account, is it possible for a person who has a bank account whose age is 80, whose age is 85, whose age is 78, is it possible for them to have a bank account still having the balance? Is it possible? Or is this outlier in this context? Savings bank account point of view, are they outliers? These are non-outliers. These are possible. What do you think? If the business context is loans portfolio, this age is outlier. If the business context is savings banks or fixed deposit, then these are non-outliers. So always underlying business dictates what is an outlier, what is not an outlier. Do you agree with that point? It's not just the numbers. It's the business context also decides what is an outlier, what is not an outlier for me. Agreed? So always outlier should be decided based on stats. Look at the percentile distribution plus underlying business context need to be also considered. Okay. Our behaviors are customers done by data, or any team are monitoring these customers. Teams are monitoring the customers using the data. So the answer is teams are monitoring the customers using what? Using the data. Depending on how much you are spending, depending on how many late payments you are making. Based on that, obviously the teams will be monitoring. To detect the outliers, there is one more method. A visual representation can help us to detect the outliers as well. There is one more alternative. The other one is using box plots. Before box plots, we need to understand quartiles. We understand what is percentile. 1 percentile, 2 percentile, 3 percentile. Within this, there are some special percentiles which are known as quartiles. 25th percentile is known as quartile 1 or lower quartile. 50th percentile is known as quartile 2, or what is the name of this? Another name? Second quartile? Median, isn't it? 50 percentile is median. 75th percentile is third quartile or upper quartile. Okay. 100th percentile is fourth quartile or the max value. Yeah. So instead of dividing the data, if you divide the data to 100 parts, those are percentiles. If you divide the data into 4 parts, quartile 1, quartile 2, quartile 3, quartile 4, 4 quartiles are there. Okay. Q1, Q2, Q3, Q4. Now we can look at the box plots to decide the outliers. I'm going to tell you how to draw the box plots, how box plots can help us to detect the outliers in a given variable. Let me give you an example of two variables, variable X and its quartiles. Quartile 1, which is, or let me start with percentile 0, which is the minimum value. Percentile 25, which is quartile 1. Percentile 50, which is quartile 2 value. Percentile 75, which is quartile 3 value. Percentile 100, which is quartile 4 value. The values, corresponding values, these are the percentile. The corresponding values of variable X are minimum value is 0. This is 12. This is like 26. This is like 40. This is 55. These are the values for variable X. Let me give you variable Y. Percentiles, value. This variable is different variable. This is variable Y. P0, which is minimum. P25, which is quartile 1. P50, quartile 2. P75, quartile 3. P100, which is quartile 4. The values are 0, 12, 26, 40, and 5 million, 50 lakhs. Okay. Let us draw the box plot for variable X. A box plot is drawn by showing all the quartile values. The box plot contains 5 values. For any variable, a box plot is drawn for one variable. Here the variable is X. Okay. On the y-axis, you have the percentiles P0, P25, P50, etc., etc. So let us see. you have this minimum value, which is 0. This is P1, which happens to be 12. P1, which is, or Q1, which is P25. 25 percentile value is 12 for this variable. Then 50 percentile value is how much? Around 26. This is 26. This is P50, which is also known as Q2. Let me write simply Q2. The 75 percentile value is 40. That means 75% of the data in X is below 40. 40, this is Q3. Maximum value of X is around 55. And we join this Q1 to Q5. This is the box plot of variable X. How box plot is drawn? P0, P25, P50, P75. Okay. This is 55. This is 55. And P100. That's it. That's how you draw the box plot. Okay. This is the box plot for variable X. Now let us draw the box plot for variable Y. Are you ready? Box plot. Is it easy to understand? What is a box plot? A box plot contains exactly these numbers. That is a box plot. Let us draw the box plot for variable Y. By the way, what is the minimum value of variable Y? Variable Y. Look at variable Y here, this one. What is the minimum value? 0. What is the maximum value? 100 percentile. What is the maximum value? 5 million.
5 million.
So in this graph, I have to put this from 0 to 5 million, right? This has to be 5 million, isn't it? 5 million, 50 lakhs. 0 to 5 million, yes or no? So that means from here to here, 1 million, 2 million, 3 million, 4 million, and then 5 million will come. Agreed or not? Otherwise, 5 million, this graph I want to show here, I have to be little bit changing the scale because my values vary between 0 to 5 million. Now, let us draw the box plot for variable Y. What is the minimum value? 0, it will come here. What is the 25 percentile value for variable Y? I'm talking about variable Y. What is the 25 percentile value?
26.
For 25 percentile value for variable Y, look at this carefully. 12, where it will come? Somewhere here only? Yes or no?
Yes, sir.
What is the 50 percentile value?
26.
Where it will come? Here only, because from here to here it is 10 lakhs. What is the 75 percentile value?
40.
What is the maximum value? 100 percentile value? This is the box plot. This is the box plot for variable Y. Is it a box plot, first of all? Is it a box plot? Whether you agree or not, it is a box plot. Yes or no? Doesn't look like a box plot, but it is a box plot. Yes or no?
Yes.
It's a box plot. But why this is like this? Why the box plot is like this? Why it's not like well spread like this? Tell me, what is the reason? In this, we can clearly see. In this, we can clearly see. Is it the scaling issue? That's why it's like this. Or what is the real issue? Understand the real issue. What is the real issue?
Because of outliers.
There are outliers. When there are outliers present in the data, the box plot of that variable will be, the box will be compressed either this side or this side. If you have high side outliers, the box will be compressed here. If you have low side outliers, the box will be compressed here. Otherwise, the box will be compressed in the middle. Can I say until here, 75% of the data is covered until this limit? Agreed or not?
Yes,
Until this limit, 75% of the data is covered. That means 75% of the data is lying here. Rest of the data is going as high as this one. Definitely there are some outliers. So box plot is drawn by looking at the P0 minimum first quartile, P25, median P50, third quartile, P75, maximum value P100. When you draw a box plot, if you see a relatively good distribution, if you see a fair distribution, then you can say there are no outliers. If you see a little deviation, until here, what percent of the data is covered? Tell me. Until this point, what percent of the data is covered? How much percent until this point?
75.
75.
This is P75, which means what? 75% of the data is covered. 75% of the data is below 15. Sometimes some values are going into 120. There are some outliers. Now look at this. Is this a box plot? This one? Is this a box plot? Yes, it is a box plot. But why is it like this? This one has some outliers, a few outliers. This one has extreme outliers. Agreed or not? When you see a box plot like this, what do you understand from there? This one has extreme outliers. Will you be able to look at a plot and decide whether there are outliers present in that or not? Will you be able to do that? Looking at the box plot. If the box plot looks somewhat like this versus like this, will you be able to detect it?
No, sir.
So when you look at the box plot, you can get a quick idea. When you have two variables, if a variable's box plot is somewhat like this, perfect distribution may not be possible. At least if it is near to this, then we would say there are less outliers. If the plot is somewhat like this, then we will say there is a bit of outliers. To exactly detect it, then we have to do percentile distribution, etc., what we did earlier. But if the box plot is like this, then there is no question about it. Definitely there are outliers. If the box is compressed either downside or upside or in the middle, then there are for sure outliers are present. Just to recap this, what I want you to do is draw a box plot in the bank telemarketing data, draw a box plot for bank balance, draw a box plot for age. Tell me. Yeah, Sabisach, tell me. Any question? Please go ahead.
No, sir. No, sir.
Okay. Okay. So draw a box plot for bank balance, draw a box plot for age, and look at those two box plots. Tell me whether this one has outliers, this one has outliers, both of them are outliers, or one of them have outliers. Go ahead, draw the box plots for these two variables and let me know, are there any outliers? Basically, we want to have a quick visual inspection instead of going through this lengthy method. This is a perfect method, no doubt about it. If you want to have a quick visual inspection, you can import the data, you can look at the columns and quickly can draw the box plot for balance. This is how it looks. Box plot for age. Look at balance, look at age quickly with a single look. What can you say about balance? What can you say about age? For sure, balance has outliers. There is no doubt about it. You cannot see the box. Yes or no? For sure. Age seems to have some outliers, but it is not as bad as balance. Agreed or not? Age is also not a perfect distribution. Age seems to have some outliers, but this one is not as bad as balance. Balance will definitely has outliers. Age also has some outliers. Age also, if you see age variable, this also minimum value. This is P0, P25, P50, P75. This is the limit that Python is suggesting us. Python is suggesting these as outliers. This is the P100. The top one is P100. These are the suggested outliers. Okay. These are the suggested outliers. Based on some internal metrics, it has calculated suggested outliers. It has outliers, but comparatively, balance definitely has outliers. Maybe age beyond 70 can be considered as outliers. That's what Python is suggesting us. But compared to balance, if you go to balance, that is pretty bad. Like here, looks like a lot of outliers are there. For a quick visual inspection, box plot can be used for detection of the outliers. But if you really want to know exactly what percent are outliers, 1%, 2%, 3%, or 5%, we have to look at the percentile distribution. Percentile distribution. Yeah. What is the logic behind suggested outliers? I think internally what they take is they take P75 minus P25 into some 1.5 times or 2 times or 3 times like that. So the difference between this one and P75 plus this one, until here they will put a limit, and these are the suggestions. What you can do is simply ignore that and consider this as the whole box plot. Okay. For us, the complete box plot is this. This is also not 100% perfect. A little bit of outliers are there, but comparatively balance definitely has outliers. That is how you can check whether there are any outliers or not in a given variable. You can consider this as a quick visual inspection, but the perfect method of detecting the outliers is again what we have discussed earlier in our example, where you have looked at the percentile distribution. That is the perfect way of doing at the outliers. Looks like someone has a question. Please go ahead. You're about to ask something.
So if there is a suggested outlier, we do not have to remove it, right?
For removal, what we need to do is we have to go back to the previous method of finding the outliers. Until now, we haven't discussed about the treatment. In the next class, I'm going to tell you, depending on what percent outliers are there, always removal is not a good idea. Removal means deleting the data. Deleting the data is not always a good idea. The treatment I'm going to tell you later. Okay. This is only detection. Okay. The treatment is upcoming.
Okay.
What to do with outliers?
Yes. Okay.
Any other questions on this? You're not able to hear me? Can you quickly confirm? Are you able to hear me, everyone?
Yes, sir, we are able to hear.
Okay.
Yes, sir.
Okay.
Sir, is the box plot is used to detect outliers, or there are any other purposes as well?
Main purpose is to detect the outliers or to get an idea on the distribution, overall distribution. You can get a quick summary kind of thing. Let us suppose if you have 200 variables. Okay. Doing the percentile distribution of each and every variable may take a lot of time. Within 200 variables, you quickly create all the box plots. Some variables will look good. You can ignore them. So let us suppose out of them 50 variables have shown extreme box plots like that, balance and all that. Then we shortlist them. We filter out this. Then do the treatment. That is the major use of the box plot. Box plot tells you the whole distribution of the variable and the limits. Let's say if you take this variable, it is varying between 20 to somewhere around maximum value 105 or something. And 25% of the data is here, 50% of the data is here, 75% is here, and remaining percentage is here. Like that, you can get an idea on the data. You can think box plot as a simple visual representation of the percentiles, important percentiles. Earlier, we looked at all the percentiles. Here, we are specifically looking at P0, P25, P50, P75, and P100. Specific values only we are looking at. Right. Any other connected questions, please go ahead. Well, if there are no more questions, that is it for the discussion today. I'm going to stop the recording then. Okay. Chetan, you have a question? Please go ahead, Chetan.